Hi again, grade 12s. We will now move to a second subsection for differential calculus. We will be looking at average gradient. This is also a topic that we've already covered previously when dealing with functions. Basically, grade 12 calculus, it's a continuation of functions. It's a combination of functions, and you will see that it will also be looking at your measurement. So this topic, as it may sound or look like it's new, it's actually a combination of topics that we've already covered in your previous grade. So average gradient, I believe by now you know what is an average gradient. It's nothing new, but we'll see how this average gradient is used in calculus. Now let's start by looking at gradient. Gradient has to do with the slope of the graph. Okay, for example, if you are given an equation y is equals to 2x plus 5, and we know that the general equation for a straight line is y is equals to mx plus c, where m is your gradient. So we can say the gradient of this line, the slope of this line, is equals to 2. Okay, that is just the basic. Now average has to do with approximation. Why? Because we will mostly be looking at a gradient of curves. Basically average gradient for calculus will be looking at a gradient of a curve, most specifically looking at your hyperbola, your quadratic function, or also known as parabola. We are calling it an average gradient because we are not getting the actual value for the gradient. We are looking at your approximation. Coming back to your straight line graph, if we have a straight line like this, and we are asked to determine the gradient between these 2 points, you will agree that you will get a positive gradient, and the value that you're going to get there is going to be an actual gradient of a line. It's not an approximation. But when you look at a curve like this, and you're asked to determine the gradient between those 2 points, you will see that it's an average, it's an approximation, it's not an exact value. Okay, now let's look at an example here. Let's say we are given, that's not what I want. Okay, let's say we are given this equation, no, not this equation, this graph going like there. Okay, and we are given a point there. We are given a point there with coordinates 5 and 6, and a point there minus 1 and minus 2. So this will be point A, and this will be point B, and we are asked to determine the gradient. Since it's a straight line, we can get a gradient, an actual value for the gradient, not an approximation. So as you may recall from your analytical geometry, the equation for a gradient is equals to change in y over change in x. In this case, it will be y2 minus y1 divided by x2 minus x1. So we may say, since this is a, this will be x1, this will be y2, y1, this will be x2 and y2. Okay, so if I substitute this, I will get, what is my y2? My y2 is 6, my y1 is minus into minus 2, and then my x2 it's 5, and then my my x1 is going to be 1. So this will give me 6 plus 2 will give me 8, and then 5 minus 1 will give me 4, and my answer will give me 2. So that's the actual gradient of this line, of this line between A and B. Okay, so it's and you can see it's positive because it's an increasing function, this line, this straight line, and yeah, that's why the gradient there is positive. Okay, now let's look at average gradient and where it applies. Again, we are given what happened there? We are given a parabola like this, and we are asked to determine the gradient between point B here, a point there, and a point there. Okay, so we are given the coordinates there as -2 and 10, and the coordinates there is -6 and -2. This is a curve. If I take a line here and I join the 2 points, you will see that you will see that here we're gonna have an average because the line joining the 2 points here is gonna give us an average. It's not an actual straight line, so we use a straight line to determine the average gradient of this curve between 2 points, the 2 points there, A and B. So since we are not going to get an actual value, this is what we call an average gradient. An average gradient doesn't have a symbol, so we say average gradient. It will be given by 10 minus into -2 minus 2 minus into -6. This will give me 10 plus 2 is 12, and this will give me -2 plus 6, -2 plus 6, this is 12, minus 2 plus 6 is the same as 4, and the gradient there will be 3. But this gradient is not an actual gradient, it's an approximation, and that's what we call an average gradient. Okay, now let's have a look at this example here. If I may just leave this. And this example, it will combine what we've already done when we're dealing with what we call a when we're dealing with functional notation. So we've got an example today. Number 1. It says, what is the average gradient of g of x, which is equals to x into x plus 3 between the points x minus 5 and x minus 3. So we are given x values. For us to get y values, we must get, yes, we are given x values, and we know from our gradient equation, we must also get y values. So we must get y value. So we'll say this is 1, this is 2. We must get y value 1. Sorry, y value number 1 and y value number 2. Now, how do I get these values? Now, I take my general equation that is given, and I say, okay, I'm given that g of x is equals to x plus 3. Now, what I'm going back to what I covered in the first video where I was dealing with functional notation. So I'm looking for an y value when x is minus 5. So I'll say, okay, I want a y value when x is equals to minus 5. So this will be minus 5. So basically this means that where I see x, I put minus 5. Where I see x, I put minus 5. This will be minus 5 plus 3. And this will give me minus 5. Minus 5 plus 3 will give me, minus 5 plus 3 will give me minus 2. And the answer that I will get there, it's 10. Okay? I come back here and say, okay, again, I want the y value number 2 when x is equals to minus 3. So I'm given an equation g of x, which is x into 3. And I say, what will be my y value when x is equals to minus 3? This will give me minus 3 plus 3, close bracket. Okay, 3 plus 3 will give me 0. And any number multiplied by 0 is 0. So this will be 0. So my coordinates here is going to be my x value is minus 5. What is my y value? My y value here it's 10. Coming back here, my x value it's minus 3. What is my y value? My y value is 0. And then if this is point A, this is point B, I don't know what happened here. Point A, this is point A, and that is point B. And my gradient, so we are looking for average gradient, and there's no symbol for average gradient, so we have to write it and say average gradient will be given y at A minus y at B divided by x at A minus x at B. This will be y at A, it's 10 minus into minus 3 divided by what is x at A. X at A is minus 5 minus into minus 3. And this will give me, oh, I see that I made a mistake. Y at B is 0, so this is supposed to be 0. Okay, minus 0, 10 minus 0, it's 10, and then negative 5 minus into minus 3, it will give me negative 5 plus 3, negative 5 plus 3 will give me negative 2. This will give me negative 2, and the final answer will give me negative 5. And that is what you call an average gradient. Okay, so now that we managed to see how to get your gradient when you have a straight line and your average gradient when you have a parabola or a curve, let's see how we can generalize this whole concept. Okay. Okay, now let's draw another graph here. And now let's say we are given a parabola again like this, and we want to look at the gradient between these 2 points, that point and that point and that point. We can agree that the straight line will pass there. Okay, and this clearly shows that what we'll get here is not a gradient but an average gradient, as it will give us an approximation. Okay, now let's say this point here, or the coordinates here for A, it's x1 and x2, and here it's not x2, sorry, x1 and y1, and here x2 and y2. Now if we were to determine the gradient, the average gradient will be given average gradient 2 minus y1 divided by x2 minus x1. Now you may ask a question that why are we really interested in doing this? Now this brings us to a very important section which will help us when we start looking at your limits and your differentiation using first principles. Again, I will draw another graph. I'm doing this so that I can show you how certain formulas were developed. It's very important to understand where formulas were developed so that you can know when and how to apply them. Let me draw another graph here. What happened? If I may select the correct graph here. Now I will look at a different graph. I will look at a hyperbola going there and going there, and I want to look at a gradient of this line between this point and that point. I don't know why this pen keeps on doing this. Okay, so we can agree that my line will go there, which clearly shows that this will give us an average gradient. We can't get an actual gradient here. Okay, so we can agree that this point here, let's say this point is x, and this point here, it's h units from x. So from me to get to this point, I must travel h units. For example, let's say this was -5, and then for me to get this point here, I must add 2. So it means this point here will be -5 plus 2, which will give me 3. Okay, so there's nothing wrong with that. And then I will call this point, if I may just remove this to get a space for writing. So we can agree that this coordinate here will be given as x, and the y value there will be given as f of x. We can agree that f of x is the same as y. And here, this coordinate here will be given as, this will be x plus h. So the x value will be x plus h, and the y value will be f of x plus h. I'm sure now if you know how that this is correct when you start looking at your functional notation. Now, if I were to ask to determine the average gradient of this line, I would say average gradient is y2 minus y1 divided by x2 minus x1. Now, which one will be y2? This will be 2 and this will be 1. My y2 will be f into x plus h minus, what will be my f? My y1. My y1 will be this one. It will be f of x. And what will be my x2? My x2, x number 2 will be x plus h minus, what will be x1? x1 is there, it's x. So if I summarize this or I simplify this, I will have f of x plus h minus f of x, and here x and x will cancel and be left with h. That is a general equation for average gradient of a curve. Now this grade 12, this equation here is very important, and you will see when we start working on differentiation. You will see in the next few lessons what differentiation is all about. Differentiation, specifically looking at first principle. So if you've already covered this topic, you will see that this formula here looks familiar. So that will be all for this lesson, and then on the next lesson we'll be looking at your limits, and then we'll continue in the next lesson. Until we meet again, have a wonderful time. See you next time. Bye.